Welcome back to Kubernetes Crashcasts. I'm Sheila, and I'm here with Victor to dive deeper into the world of Kubernetes. Before we begin, I'd like to remind our listeners to rate our podcast on whatever platform you're listening to us. Your feedback helps us improve and reach more people interested in Kubernetes. Today, we're continuing our exploration of controllers in Kubernetes, and we'll be focusing on replication controllers. But first, let's start with a quiz question for our listeners. Victor, would you like to do the honors?
Certainly, Sheila. Here's a question for our listeners to ponder. In Kubernetes, what controller ensures a specified number of pod replicas are running at all times, even if some pods fail or are terminated? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Victor. It really gets to the heart of what we'll be discussing today. Now, before we dive into replication controllers, could you give us a quick refresher on what controllers are in Kubernetes?
Of course, Sheila. Controllers in Kubernetes are like automated supervisors for your cluster. They constantly watch over things, making sure everything is running as it should. If something's not right, they step in to fix it. Replication controllers are one type of these supervisors, and they were one of the first ways Kubernetes managed multiple copies of the same application.
That's a great explanation, Victor. So, if I understand correctly, a replication controller is responsible for maintaining a stable set of replica pods running at any given time. Is that right?
That's exactly right, Sheila. Think of a replication controller as a diligent manager for your pods. Its job is to make sure you always have the right number of pods running. If there are too many, it'll remove some. If there are too few, it'll start more. It's like having a watchful guardian for your applications.
That sounds really useful. Can you explain how it actually works?
Certainly. A replication controller is like a thermostat for your cluster. Just as a thermostat constantly checks the temperature and adjusts the heating or cooling, a replication controller constantly monitors the pods in your cluster. If it notices that the number of pods doesn't match what you've asked for, it takes action to correct the situation.
That's a great analogy, Victor. It makes it much easier to understand. So, what components make up a replication controller?
A replication controller has three key parts. Quant 1. A label selector, which determines what pods the replication controller should keep an eye on. 2. A replica count, which specifies how many pods you want running. Point 3. A pod template, which is like a blueprint for creating new pods when needed. These components work together to maintain the desired state of your application.
I see. So if I wanted to create a replication controller, I would need to specify these three things. That makes sense. Now, Victor, I've also heard about something called ReplicaSets. How do they relate to replication controllers?
Great question, Sheila. ReplicaSets are like the newer, more advanced version of replication controllers. The main difference is that ReplicaSets are more flexible in how they select which pods to manage. They're generally recommended over replication controllers in newer Kubernetes setups.
Interesting. So it sounds like replica sets are more flexible. Are there any situations where you'd still use a replication controller instead of a replica set?
Generally, it's recommended to use replica sets or even higher-level tools like deployments in new projects. However, you might still come across replication controllers in older Kubernetes setups or learning materials. Understanding replication controllers is important because they form the foundation for these more advanced concepts.
That makes sense. Can you give us an example of how a replication controller might be used in a real-world scenario?
Absolutely. Imagine you're running a popular website that needs to handle varying amounts of visitors. You could use a replication controller to ensure that a specific number of web server pods are always running. If a pod crashes or a server goes down, the replication controller would automatically create new pods to keep your website running smoothly. It's like having an automated team that keeps your website up and running 24/7.
That's a great example, Victor. It really shows how useful replication controllers can be. Are there any common mistakes or best practices we should know about when working with replication controllers?
Absolutely, Sheila. One common mistake is manually deleting pods that a replication controller is managing. This can lead to unexpected behavior because the controller will immediately create new pods to maintain the desired count. As for best practices, it's important to use clear and meaningful labels for your pods. Also, when updating applications, it's better to use deployments. They provide smarter ways to update your apps than directly changing replication controllers.
Those are valuable tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The question was, in Kubernetes, what controller ensures a specified number of pod replicas are running at all times, even if some pods fail or are terminated, or are?
And the answer is Replication Controller, or its more modern counterpart, ReplicaSets. Both of these controllers make sure you always have the right number of pods running, even when things go wrong.
Thank you, Victor. To summarize what we've learned today, point 1. Replication controllers are like automated managers that maintain a stable set of replica pods. Point 2. They consist of a label selector, a replica count, and a pod template. 3. ReplicaSets are the newer version of replication controllers with more flexible pod selection. 4. While replication controllers are still important to understand, newer projects typically use ReplicaSets or higher-level tools like deployments. Thank you all for listening to Kubernetes Crashcasts. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, keep on learning.